Good morning, my dear students. Welcome from that long break. It has been a very long break. Pardon me for that vacuum. But today, we are going to continue our lessons. But before we continue, let's look at what we did last time. Last time, we learned how to find the gradient of curves at a given point. The gradient of a curve at a given point. Now, let's pick a question. Find the gradient. Find the gradient, excuse me. Find the gradient on the curve y is equal to 3x squared minus 2 at the point where x is equal to 3. Where x is equal to 3. Let's look at the ideal solution to this question. The gradient of this curve at s is equal to 3 can be found or obtained by first differentiating the function. So we'll first find dy dx. Those who might be watching the video for the first time, to find dy dx, we are going to differentiate this equation term by term in respect to x. So we are going to multiply the power of the x with its coefficient and reduce the power by 1. Anywhere we have a constant number like this, drops off. So in this instance, we're going to have 3 multiplying the power 2, and then the power will drop by 1. So 2 minus 1. And then we'll have minus 0. This becomes 0. So this becomes 6x. So this is the gradient function. Then we'll use the gradient function to obtain the gradient at s is equal to 3. So at x is equal to 3, our gradient, which is the same thing as dy over dx, will be equal to 6 multiplied by 3, and the value becomes 18. So this is our equation, our gradient at a point where s is equal to 3. Where s is equal to 3. Now, today, we are going to look at equations of normal. Sorry, this is normal. Equation of normal. Let me correct that. Equation of normal. This is normal, L. The letter here is L. Equation of normal and tangent to a curve. Now, let's look at what is known as a normal or a tangent. If I have a curve such as this is good. A normal we're going to look at what a normal and a tangent is. A tangent is a line drawn to touch the curve. So this is a tangent. The blue line is a tangent. It's drawn to touch the curve. and the normal is drawn, is a line drawn such that it become perpendicular to the curve. So with this, the angle here is 90 degrees. The angle here is 90 degrees. So this is the normal, whereas this is the tangent. This is the normal and this is the tangent. So what we are coming to learn is to learn how to find the equation of these two lines. Before we proceed, you need to know that the excuse me, the equation, the gradient of the tangent is always the same thing as the equation, the gradient of the curve at that particular point. The gradient of the tangent is the same thing as the gradient of the curve at this particular point. But because the normal is perpendicular to the tangent, the gradient of the tangent will be negative reciprocal. Sorry, the gradient of the normal will be the negative reciprocal of the tangent. For instance, if my tangent and the tangent has an equation, a gradient of value m, if the tangent gradient is equal to m, then the normal will be the negative reciprocal. So we reciprocate this, minus 1 over m. Or if the tangent has a gradient of a over b, then the normal, which is negative reciprocal, will be negative b over a. Or if the tangent has a gradient of negative a over b, then this becomes positive b over a, negative reciprocal. So take note. So let's pick our first question for the day. First question for the day. And it says we are to find the equation of the normal and the tangent to the curve y is equal to 3x squared minus 2x plus 4 at the point where s is equal to 1. At the point where s is equal to 1. Negative 1. We have learned that the gradient of the curve at any given point is the same thing as the gradient of the tangent at the same point. Now, and we all know that to find the the equation of a line, we need to obtain the gradient. So we are going to obtain the gradient of this tangent and the normal. But before then, we need to obtain the gradient function. So we need to find out the gradient function dy dx. Let's calculate for the gradient function. The gradient function dy over dx. Those who are joining us for the first time in this lesson, to find the gradient function, we multiply the power of x with its coefficient. Here the power is 1, it will be multiplied by the coefficient here. Here it is a constant, so it will drop. So when I multiply the power by the coefficient, reduce the power by 1. Multiply the power by the coefficient, reduce the power by 1. The constant term drops. So let's come and perform that calculation here. So the first term shall have 6x. The power becomes 1 minus 2x raised to the power 0. We know that any number raised to the power 0 is 1. Hence, this will translate into 6x minus 2. At x is equal to negative 1, our gradient function dy dx, dy over dx will be equal to 6 multiplying negative 1 minus 1. And this will give us negative 6 minus 1. And that will be negative 7. Good. It means gradient of tangent is equal to negative 7. And then gradient of normal is equal to negative reciprocal of that of the tangent. So that will become positive 1 over 7. In order to find the equation of any line, the formula is y minus y1 equal m, stand for the gradient, x minus x1, where x1, y1 is a coordinate on that particular point of line. So we need to obtain the coordinate x1, y1. We've been given the x coordinate here at x is equal to negative 1. So we need to find out the corresponding y value by using the equation that has been given here. So we come down here. Y, let me write the equation again, is equal to 3x squared minus 2x plus 4. When x is equal to negative 1, we shall have 3 neg 1 squared minus 2 neg 1 plus 4. This becomes 3 plus 2 plus 4. And this becomes 9. So we're going to find the gradient at a point where x is negative 1 and y is positive 9. So this being our S1, and this being our S2. So for the tangent, we're going to have y minus 9 equal m. Sorry, the m value, negative 7. Then x minus negative 1, which becomes x plus 1. Solving further, y is equal to y minus 9 is equal to negative 7 x minus x. Y will be equal to negative 7x minus 7 plus 9. Y will be equal to minus 7x plus 2. So this is the equation of the tangent at the point where x is equal to -1. Okay, so that is for the tangent. Now let's look at the normal. We are using the same point with a different gradient. Remember, the gradient of the normal has a gradient of positive 1/7. The same point. So we have y minus 9 is equal to 1/7 into x minus 1, so we become plus 1. Clearing fraction, we have 7y, then 9 times 7. 9 times 7, which is 63. 63. Then we'll have x plus 1. We can arrange this in the general form. So we'll send everything to the other side. So we have 7y minus x is equal to 1 plus 63. So minus x plus 7y is equal to 64. The general form becomes negative x plus 7y minus 64 is equal to 0. You can leave it in this way. That's the best way. So this is the equation of the normal at a point where s is equal to -1. Let's look at another question. Let's look at the second question for the day. We are going to find the equation of the normal, this time only the normal, to the curve s is equal to 2 minus x squared at a point where x is equal to 2. Good. So let's begin. We need to obtain the gradient of the curve at the point where s is 2. And we can do that by finding the gradient function. Gradient function dy over dx. To find the gradient function, as usual, we'll multiply the powers by the R coefficients, and then we'll reduce the powers by 1. Differentiating a constant 2 will drop. So let's come. The 2, when we differentiate it, will drop. So you'll have -1. That's 1 times the coefficient -1. And the power x now of x over here now becomes 0, which will translate into 1. And it drops up. And the other term will become minus 2x. The power now becomes 1. So that's the gradient function. At x is equal to 2, our gradient function dy dx, dy over dx, will be equal to -1 minus 2 into bracket 2. That will give us -1 minus 4, -5. Good. It means the tangent has a gradient of -5, but we are after the normal. Gradient of normal will be equal to positive 1/5. Remember, the normal is obtained by reciprocating and negating the gradient of the tangent. Now, once that we have obtained the gradient, let's obtain the coordinate at which we are going to calculate our equation. Given that s is equal to 2, y will be equal to 2 minus 2 minus 2 squared. This becomes 0. So we have minus 2 squared, which is minus 4. So our coordinates where we are going to perform the calculation is 2, negative 4. And that becomes our x1, y1. And the formula is y minus y1 is equal to m, where m is the gradient, and x minus x1. Good. So substitute in values. It's y minus y. Sorry, minus 4. Okay, let me write minus 4. Bracket negative 4. It's equal to the gradient 1 over 5. Then x minus the x1, which is 2. Minus 2. Good. This becomes y plus 4 is equal to 1 over 5 x minus 2. We clear fraction by multiplying 2 by 5. So we'll have 5y plus 20 is equal to x minus 2. Grouping all together, 5y minus x plus 20 plus 2 is equal to 0. Let me write here correctly. Plus 20 plus 2 is equal to 0. So it becomes 5y minus x plus 22 is equal to 0. Rearranging, we have minus x plus 5y plus 22 is equal to 0. Is equal to 0. So this is the equation of the normal at the point where s is equal to 2. Let's look at the third question for the day. If y is equal to 3x plus q is a tangent to the curve y is equal to x squared minus 2x minus 3, find q. Now, we know that if I have y is equal to 3x plus q, then 3 is my gradient. 3 is my gradient. Note that at the GSS, you were taught that the equation of a line is a form y is equal to mx plus c, where m is the gradient. So the gradient of the tangent is 3. Gradient of tangent is 3. The gradient of the tangent is 3. But note that the gradient of the tangent is the same as the gradient of the curve. Y is equal to x squared minus 2x minus 3 at the point of contact. So let's find the gradient function for this curve. The gradient function is dy dx. And as usual, we're going to multiply the power by the coefficient here and reduce the power by 1. Those who are joining the class for the first time, this should not be a problem. Now, at least, This is the third time I'm solving this. So 2x minus 2. The 3 drops off. Good. It means the 2x minus 2, which is the gradient function, is giving us the value 3. So we need to obtain the x value for which the gradient is 3. So continue solving. We'll have 2x is equal to 5. That's when the 2 crosses. Become plus. And our x becomes 5 over 2. Or otherwise 2.5. So if x is equal to 5 over 2, let's find the y coordinate. The y coordinate by using the equation y is equal to x squared minus 2x minus 3. So to find the y coordinate, we just substitute our x value 5 over 2 all square minus 2, 5 over 2 minus 3. This becomes 25 over 4, 25 over 4. And this becomes minus 5, this becomes minus 3. Solving further, you can use your ES calculator, get negative 7 over 4. So it means that at the point 5 over 2, comma, negative 7 over 4, that is where our line is a tangent. If the lines are tangent to this point, then it will satisfy this point will satisfy the equation of this line. So we'll pick these 2 points and substitute it into the equation of the line to solve for our Q. Remember, this is the x coordinates, this is the y coordinates. So picking the equation, y is equal to 3x plus q, we'll substitute in negative 7 over 4 is equal to 3 multiplying 5 over 2. 5 over 2 plus q. Then we group like terms. So our q, we'll send this one to the other side. So it becomes minus 7 over 4 minus 15 over 2. In fact, when I multiply these values, you get 15 over 2. Then we perform the subtraction. We're going to get minus 37 over 4. Minus 37 over 4. That is that. That's the value of Q. Let's look at our fourth question for the day. Find the coordinates of the points, the curve, y is equal to x cubed minus 2x squared minus 2x minus 3, where the tangent is parallel to the line y is 2x plus 1, y minus 2x plus 1 is equal to 0. Now, when two lines are parallel, like what I've just sketched, the gradients are the same. Parallel lines have the same gradient. It means the gradient of the tangent will be the same thing as the gradient of this line, since they are parallel. Okay, so now let's obtain the gradient of this line. Once we obtain the gradient of this line, that becomes the gradient of the tangent. We have to rearrange this equation into the form y is equal to mx plus c. so that we can obtain the gradient. The gradient is always the coefficient of x when you have arranged it in this form. So arranging that equation becomes y is equal to positive 2x minus 1. It implies our gradient is equal to 2. Since the gradient of the tangent is also the same thing as the gradient of the curve at the same point, at the point of contact, you can say our dy over dx, which is the gradient function, is equal to 2, this 2. Good. And what is our dy over dx? Let's go and obtain the equation dy over dx. dy over dx. We are going to differentiate this function the same way we've been doing. We are going to multiply the powers of x by their coefficient and reduce the powers by 1. So this 3 will multiply the 1 here, reduce the power by 1. This 2 will multiply the 2 here, reduce the power by 1. This has power 1 to multiply the 2, and the x will drop. Constant term will always drop. So this one is going to give us 3x squared. 3x squared minus 4x minus 2. So our 3x squared minus 4x minus 2 will give us 2. So rearranging 3x squared minus 4x minus 2 is equal to 0. 3x squared minus 2 is equal to 0. This becomes 3x squared minus 4x minus 4 is equal to 0. It's a quadratic equation, so we'll solve. We are going to factorize. I hope you know factorization already. So 3x squared, we want to split the 4x into two numbers such that when you multiply the two numbers, you will get negative 12. But when you add, you get negatives 4. The two numbers are negative 6 and 2. So we have minus 6x plus 2x, minus 6x plus 2x minus 4 is equal to 0. Factorizing further, we have 3x coming out. Then we have x minus 2. Then for this side, we have 2 coming out. We have x minus 2 is equal to 0. So this becomes 3x plus 2. X minus 2 is equal to 0. That means the values of x are x is equal to minus 2 over 3, comma, positive 2. Good. So we must find the coordinate. We are finding the coordinate. So we are going to substitute in these two values to find their corresponding y coordinate. And the equation is y is equal to x cubed. I'm just rewriting the equation. X cubed minus 2x squared minus 2x minus 3. When x is equal to negative 2 over 3, we'll have minus 2 over 3, all raised to the power 3. Then minus 2 over 3, all raised to the power 2. Then minus 2 into brackets minus 2 over 3. Then minus 3. Good. Good. Let's proceed. I want you to solve this yourself. I'm just writing the answer. Solving this, we'll have minus 77 over 27. Negative 77 over 27. So that is one coordinate. And s is equal to, s is equal to minus 2 over 3. The coordinate is minus 2 over 3, comma, minus 77 over 20, minus 77 over 27. Good. But when s is equal to 2, our y coordinate will be y is equal to 2q minus 2 into brackets 2 square minus 2 into bracket 2 times 2 minus 3. Solving further, the value of your y becomes negative 7. So we'll get the coordinates 2 comma negative 7. So these are the coordinates, and the coordinates are the point where y is equal to the gradient of the tangent is parallel to the line y minus 2x plus 1 is equal to 0. So take note, I'm going to give you some few questions for you to try at home and submit it within the course of the day for marking. Thank you. Okay, pause the video now and copy the assignment and try your hands on them. Try to submit this assignment today by 6 o'clock p.m. Do not submit them to the page. Submit them privately to me. Thank you.